Hello everyone, welcome back to Math and Physics Simplified. Let us discuss the summary of the chapter pair of linear equations in two variables. First of all, we have to understand what is linear equation. Okay, so if you write some equation x plus 1 equal to 0 or x minus 9 equals 12 or something else like this, we can say the power of this equation is 1, right? So we can call the equation as linear equation, and if the expression is in the form ax plus b, we can call it as a linear polynomial, right? But if the power is a square term, suppose x square plus 2x plus 1 equal to 0, we will call it as quadratic equation, right? And what is variable? Variable means that changes. In this equation, x can be varied, right? X can be changed. We cannot say it's a constant value, and we will solve it, but it's a variable. And if it is another variable also included, y, we call it as two variables are there in the linear equation. Okay, so we will discuss pair of linear equations, because if there are two variables x plus y equals 2, we can't solve it using one equation. We should get minimum two equations to solve two unknowns. Okay, if we have two equations, definitely we will get two lines to draw, right? We will get two lines to draw, and we can represent and solve these equations using two methods, graphical method and algebraic method. We will discuss only graphical method in this video. Algebraic method we can discuss it in the next video. Okay, so in graphical method, I told you if we have two equations, we can draw two lines, and according to the line, whether it is intersecting or whether it is just passing and whether it is coinciding, we can decide the nature of the solutions. Okay, nature of the solutions. What is solution actually? The value for x and y. If there are three variables, we can use z also. Okay, so graphical method, and if we get x-axis, y-axis, we can definitely draw lines in this. Numbers will be here, and if you have any difficulty in drawing graph, please let me know in comments. So if we are drawing two lines, and if it is intersecting at one point, only one point it is intersecting, we can call this equation, these equations will have unique solution. Okay, unique solution. And the system is independent, and as we are getting a solution, we can say it is consistent. Okay, if two lines intersect at one point. Okay, and there is another chance of drawing lines, but when you draw lines, we are getting two lines on the same line. Okay, the slope is same for these two lines. Okay, but here we will get infinitely many solution, right? Here we will get infinitely many solution, because each point in this line is a solution, right? Okay, so as we are getting solutions, we call it as consistent, and the system is dependent. Dependent because it has same slope, right? Here for the intersecting lines, sorry, intersecting at one point, here the slope is different, right? Slope is different. Okay, and there is one more chance. If you are drawing two lines and x-axis and y-axis, there is a chance of drawing these lines parallel to each other, right? They never meet each other, so we don't get any solution. So no solution for this system of equations, and so we can say it is inconsistent. And they have different y-intercept. You know what is y-intercept? When the line passes through the y-axis, where they touch the y-axis, that point is called y-intercept. And we can say in another way, for y-intercept, x value will be 0. Okay, at the particular point, x value will be 0. So that y-intercept is different for parallel lines, right? So we can say they are independent. The system is independent. Okay, it has no solution, it is inconsistent, the system is independent. And if we don't have graphs, we can find the nature of solution by using these ratios a1 by a2, b1 by b2, and c1 by c2. And what is a? A is the coefficient of x. What is b? It is coefficient of y. And c is the constant in that is the y-intercept constant. Okay, so a1 by a2 we can find the ratio from these two equations. a1 by a2 is, here it is 1 and here it is 5, so a1 by a2 is 1 by 5. And what about b1 by b2? It is minus 7 divided by 2, and c1 by c2 is 11 by 18. Okay, definitely a1 by a2 not equal to b1 by b2, not equal to c1 by c2. So if a1 by a2 not equal to b1 by b2, this condition satisfied for it is intersecting at one point. Intersecting at one point means it has unique solution. And definitely we can say, as we have a solution, we can say it is consistent. And as they are not equal, we can say it is independent. Okay. And what about, yeah, we can do this. Suppose a1 by a2 not equal to b1 by b2, we can fill this. Please help me to put a tick mark here for the correct choices. Intersect at one point? Yes, absolutely. Consistent? Yes, we are getting a solution, right? Inconsistent? Wrong. Dependent? No, it is intersecting at one point and they are not equal, so not dependent. It's independent. Coincident lines? No. Unique solution? Yes. So we can put wrong mark here. Infinitely many solution wrong, parallel lines wrong. Okay, this is correct. Very good. And what about these two equations? a1 by a2, we can find 2 divided by minus 4. 2 divided by minus 4 is minus 1 by 2. b1 by b2, minus 3 divided by 6. Minus 3 divided by 6 is again minus 1 by 2. And what about c1 by c2? 1 by 5. So we can say a1 by a2 equals b1 by b2. Okay, the slope is same but not equal to c1 by c2. Y-intercept is not same. So we can say these lines are parallel lines. Correct? The ratio of coefficients are same. These are parallel lines, and parallel lines means we can say there is no solution, and so it is inconsistent. And as their y-intercept is not same, we can say system is independent. Okay, so here what is the situation? a1 by a2 equals b1 by b2 but not equals c1 by c2. Is that right? So which are the points you will mark as correct? These are parallel lines, right? Parallel lines. So intersect at one point? Never. Consistent? No, we don't have any solution for this, right? And inconsistent? Yes. Dependent? No. The y-intercept is not same, so it is not dependent. Independent? No. Coincident lines, it's wrong. Unique solution is wrong. No solution? Yes. Yes, it doesn't have any solution. Infinitely many solution? Wrong. Parallel lines? Absolutely parallel lines. Okay, hope you also made it correct. Let's move to next set of equations. Y equals minus 4 by 5, 5 by 4x minus 5 and something like that. We can rewrite the first equation, okay, like we can make this number here. So y plus 5 by 4x plus 5 equals 0. Is it correct? Y plus 5 by 4x plus 5 equals 0. And we can compare these two equations to find the ratio a1 by a2. And the coefficient of x is 5 and coefficient of x is 5 by 4 here. So 5 divided by 5 by 4, that is 5 times 4 by 5. 20 divided by, that is 4. And for the second b1 by b2, 4 divided by 1, that is also 4. c1 by c2, minus 20 comes here and it becomes positive 20. 20 divided by 5 is 4. All these ratios are same. Okay, a1 by a2 equals b1 by b2 equals c1 by c2. So if everything is same means it's the same line, Okay, y-intercept is same and the slope is also same. If it is same line, we will get infinitely many solution. Okay, and as we are getting solution, we can say it is consistent. Definitely it is dependent each other because it has the same y-intercept. Okay, please help me here. Here it is a1 by a2 equals b1 by b2 equals c1 by c2. Intersect at one point? No, it is not only intersecting at one point. As we are getting solution, it is consistent. We can mark wrong here. Inconsistent. Dependent? Yes. Independent? Wrong. Coincident lines? Absolutely. Unique solution? No. No solution? No. Infinitely many solution? Yes, correct. Parallel lines? Wrong. Okay, very good. I am just making a conclusion here. So we are considering the slope. If it is different, the two equations, okay, ax plus by plus c equals 0. Okay, a1, b1 and c1 and a2 x plus b2 y plus c2 equals 0. If two equations that slope is different, we can say the lines are intersecting at one point, okay, and consistent, and it is independent. You can pause the video and please note it down. It will be definitely useful for you. And the slopes are same. There is a difference in y-intercept. What is y-intercept? We are drawing x and y axis. Some graph we can draw here, and at which point the line is touching the y-axis, intersecting at y-axis, or at the particular value x is equal to 0. At that point is called y-intercept. If the y-intercept is different, we can call the lines as parallel lines, and it is inconsistent and the system is independent. And if the y-intercept is same, we can say the line is the same line and it is consistent, dependent system. Okay, hope you understand everything. If you are new here, hit the subscribe button so you make sure to never miss my videos. Thank you.